Welcome to Get Your FRQ On. This question is from 2007. It's from the B exam. It's question 1, and it is calculator active. In the question stem, we're given a function, a portion of its graph, and two regions defined in the graph, R and S, separated by horizontal lines. In part A of the question, we are asked to find the area of region R. Now, in order to do this, we have to know when the function, which provides the boundary, is going to equal the horizontal line y equals 2, because that's the horizontal line that is the lower boundary for this region R. But we don't know where these two things intersect, so we don't know the bounds. So we're going to use our calculator to determine the solutions to the equation e to the 2x minus x squared equals 2, so we know what our bounds of integration will be. Right? Those points of intersection occur at x equals 0.446057, which I'm going to call A, and x equals 1.553943, which I'm going to call B. All right, then the area of region R is given by the integral from A to B, of e to the 2x minus x squared minus 2 dx. And since it's a calculator active question, I'm going to let my calculator figure out what that area is. It's 0.514. In part B of the question, we are asked to find the area of region S, which lies directly beneath R, but still not on the x-axis. So in order to calculate the area of region R, we could either do a very complicated integral or a slightly less complicated integral. All right, we need to know when e to the 2x minus x squared is equal to 1, since that is the lower boundary of region S, so that we can use the appropriate bounds of integration. Again, it's a calculator active question, so use your calculator. And it turns out that these points of intersection are precisely at x equals 0 and x equals 2. Great. But here's the problem. We want to integrate from 0 to 2, but we don't want to include the top portion of the area bounded by the graph in the x-axis, because the top portion is actually region R, it's not region S. So the way we're going to handle this is we are going to calculate the integral from 0 to 2 and just subtract the area of region R. Right, we found the area of region R in part A of this question, so we have its value. So to find the area of region S, we're going to integrate from 0 to 2, e to the 2x minus x squared minus 1 dx, and then we're just going to subtract off the area from part A, which is 0.514. Again, it's a calculator active question. Let your calculator do the work. And we get 1.546. In part C of the question, we are asked to write an integral for the volume when the region R is rotated around the line y equals 1. Notice we only have to write the integral. We do not need to actually find that volume. All right, so in order to calculate the volume when R is rotated around the line y equals 1, R does not rest on this line, so this is going to be an application of the washer method. So I have to think in terms of a big radius and a little radius. Also, since we're rotating around a horizontal line, we're going to be integrating with respect to x. So my big radius is going to be the difference between R, or the curve, e to the 2x minus x squared, and the axis of rotation, which is 1. All right, my little radius is going to be the difference between the lower boundary of this region, which is the horizontal line y equals 2, and the axis of rotation, which is 1. So that's 2 minus 1, that's 1. So the integral that I would use to calculate this volume would be pi times the integral from a to b of my big radius function squared, e to the 2x minus x squared minus 1 squared, minus my little radius function squared, which is 1 squared. But since I don't have to evaluate this, once I write a correct integral, I can stop.